Hi everyone, welcome back to the Maths with Addy. So this week we'll be doing transformation, which is another Addy's topic. So let's get right into it.
Okay, so today we're doing transformation. So I cannot really show you how to do the rotation as in like you are allowed to use a tracing paper in your exam. But here I can't show you how to do with a tracing paper. So we're just gonna like use the other way to figure out how to do the rotation. But during the exam you are allowed to use the tracing paper. So you can bring a tracing paper into your exam and you can use it when you do this transformation like rotation. So let's go on to the first question. So it says that the grid opposite shows triangle A. We should have a grid here, right here. Says like the triangle A is transformed to triangle B by reflection. So first one's reflection with equation x equals 1. If you see that it shows says reflection x equal to 1, it's the best thing to draw like a reflection line at x equal to 1 so you know that this is where the reflection is going to happen. Okay. And then it just says like on the grid draw and label triangle B. We just need to draw a triangle B where it is reflected. Here the easiest way is you can count 1, 2, 3, 4, 5, 6, right? There's only 1, 2, 3, 4, 5, 6. So that's going to be here. And that's the same for grids. So that's going to be at -9. Wait, let me just get this off. Should be here, here. So it's going to be here. Okay, it's just a little wobbly. Just try with this. Yep, and that is your triangle B. And that's just a reflection. And then it says triangle B is transformed to triangle C under the translation 7 minus 3. So we just do the translation from B to C. So it says 7 minus 3, yeah, it means we're going to go right. If it's like positive, we're going to go right. If it's negative, we're going to go left. And for the, because it says 7 minus 3, for the down one, if it says minus, we're going to go down. But if it's plus, it goes up. So 7, we're going to go right. 1, 2, 3, 4, 5, 6, 7. I'm going to go 3 down. 1, 2, 3. So it's just going to be here. That's the, this one. So then you have like 4. Should be at -2. It's just 2, so that's just going to be here. And that is your triangle C. And then let's see. It says triangle C is transformed with triangle D under the transformation with matrix M. So they've given you the matrix, and then you need to draw on the grid draw and label triangle D. So for C, we know that this one stands for X, this one stands for Y. So let's try to figure out first. For C, what's the first coordinates? -2, -1, 2, 1. -2, 1. And that's 2, 1. And the other one should be -1, 3. And because we know that it is X, right? And the matrix is 2, 0, 0, -2. So that's X and Y. So just know that we just need to multiply all the X's with 2 and all the Y's with 2. So then it's I will show you the first form should be that X prime. That's gonna be, you have -2 right here, and then you multiply with just 2. So that's why you got -4. And Y prime, you get the -2, yeah? So that's here is 2. 2 multiply -2. Oh, sorry, not 2. This one, Y. Oh, sorry, 1. 1 multiply -2, so that gives you -2. So that's your first coordinate that is corresponding to this, which would be -4, -2. And you do the same for all 2, 1, and then the -1 and 3. So what you will get here, 2 multiply 2, 4, 1 multiply -2, another -2, and then -3 as well, that you will get -2. 3 multiply -2, that's -6. So these are your coordinates. So it's -4, -2. So that's right here. And 4 -2. And then you have -2, -6. So -2, -6. So that's right here. So you just draw this. And you can see that this is D. Oh, sorry. And then it says describe fully the single transformation that maps triangle A onto D. So A onto D, we can see that it actually got larger, so we know that it has to be enlargement, but we don't know how much by enlargement it has grown and what's the center of it. So we can try to match the points that align first. So that's going to be here first. This one matches with this. And then this one's going to be with this. And then this one's going to cross over here. And we can see that it actually matches over like twice the amount. Yeah, we can see that it's 2 times the amount of it. So which means it's going to be enlargement, but scale factor 2. So I have 2. And we can see the center where it was, which was here. That's 6,2. So you can just write center 6,2. You do need to write all 3 of this. So what's it enlarge? Is it a type of enlargement or rotation on any? And what's the scale factor if it's enlargement? And what's the center point to get full marks? Because it does say the single transformation, so you have to write all of it that concerns like how it becomes to the how A becomes on the D. Okay, we'll go on to number question 2. 2 says that on the grid opposite, trapezium B is the image of trapezium A under a single transformation. Describe the single transformation. So for A, we've got to like describe the transformation first. So here we can see that it's from A to B, I believe. Yep. Oh, sorry, B is the image, yeah, A to B. So we're gonna have to do the same thing, which is just going to be just going through the lines first. Just making sure we know where the enlargement center might be. Never mind. Let's try this one first, which I believe is actually getting closer to the 0, 0,0. So this one's a little. But yeah, we don't know that it has to be at 0,0. And we see that it's actually a scale factor of 2 as well, because it's twice the here you can see like 2, so it's like twice, so that's scale factor 2 as well. And then center at 0,0. So then you can just write that it is A, should be enlargement, scale factor 2, center 0,0. Yep. It says that trapezium C is the image of A under the reflection line at x equal to -1. So we're gonna have to draw the line first, which is x equal to -1. So this is the line x equal to -1. We just need to do the reflection, which is A's reflection. So there's just going to be at here at -4. Yeah. So I'm just gonna draw it this way. So that should be C, and that's the one that is your reflection. Yep. And trapezium A is transferred to trapezium B under the transformation with matrix M, where this is the matrix given. Draw and label C. Draw and label D again. So it's just gonna be the same thing where you multiply x's with -2 and then y's with like -1. So we can try to write down the coordinates of A first. So that's going to be here. So that's 2, 1, 1, 2. And then it's 2, 3, 1, 3. And you actually just multiply them again. So 2 minus 2, that's going to be -4, -1, and it's 1, 2, so that's -2, -2, 2, 3, that's -4, -3, and 1, -2, and 3, -3. Okay, and then you can just draw the trapezium based on these coordinates. So it's -4, -1, -4, -1, it was -2, -2, and then -4, -3, and then -2, -3. So this should be the trapezium. We'll probably just erase a little bit of these. And this is D. So yeah, we are done with D, and it says trapezium D transfer to trapezium B under the transformation with matrix N. This time we need to find the matrix N right now. So now let's try to figure out what's the coordinate of B so we can compare it with D and see what's the multiply factors for matrix. So yeah, D, and then we have to get B coordinates, right? B coordinate was 2, 4, 4, 2. And then it is 2, 6, 4, 6. So right at the back, you can actually see what's the matrix X and Y coordinates should be, because here you can see that it was, wait, we can actually try to move them around to make sure that they're coordinated the correct way. So -4, -1 was right here. -4, -1 was the sharp point. So here sharp point was 4, 2. Move it to this way, and then it was 2, -4, -3. -2, I mean. If it's -2, -2, that point was the thing, that's 1, 2. So that should be 2, 4. And then we will just switch it around. That should be 4, 6. And then 2, 6. And then right off the bat, you can see what's the coordinates that they have multiplied with. So you can see that it actually would be -4 to 4. That means it's going to multiply by -1. And then -1 to 2, that means you have to multiply -2. So that's going to be n equals to -1, 0, 0, -2. If you're unsure, you can actually double check with like the other ones as well, but it should give you the same answer for the matrix. Okay, so now off to number 3. Number 3 says that triangle A is drawn the grid opposite. A is reflected with line equal x equal -1 to give triangle B. So we're going to do x equal to -1 again. So that's going to be here. And then we've just got to do the reflection again. So that's 1, 2. So 1, 2 should be here. And that's 1, 2, 3. That's got to be 3. It's got to be here. So then you have this, this, and this. And that gives you B. So it says that A is transformed to triangle C under the rotation of 90-degree clockwise about the point of coordinates 1, 0. For this one, we can only guess for this one because I'm doing it on the iPad, so you won't be able to see how you do it with your tracing paper. But usually what you're gonna do is, it says 90-degree clockwise, coordinates 1, 0. So you're gonna draw, like, trace out this thing first. So that's gonna be your A. We're gonna trace it on your tracing paper, and you have the coordinates of 1, 0. And then you're gonna point your pen here, right here, and then you're gonna put it, and you're gonna like transform this into 90 degrees. So it has to go 90 degrees, and you will usually get, because it's center here, so for C you will get the coordinates right here. So this should be your C. So that's C. After you rotate, you will get it. But if you do it with the tracing paper, you can actually see it more clearer. But just make sure that you're doing it like when you have a rule. You can try to do it with a ruler as well. So like if you have the ruler right together with your, just if you're doing the correct 90 degrees or not. But usually if you do 90 degrees, it actually shows on the grid like where it is supposed to be. But so it should be fine. Yeah. And it says that triangle B transform to D 2, -5. So B to D. So that's 1, 2, 1, 2, -5. 1, 2, 3, 4, 5. Should be here. And I'm just gonna erase this. Assuming we can guess, it's gonna be here. Oh. So yeah, this should be D. And then it says A is transformed with E. Matrix M, you have the matrix again. So we're gonna have to get the A coordinates again. It's 1, 3, 2, 1, 3, 4. 1, 3, 2, 1, 3, 4. And I just want E coordinates. So that's 1, 1, 1, minus 3, 2, minus 1, 3, minus 4. That's 1 minus 3, 1 minus 3. I think it's 2 minus 1, 3 minus 4. 3 minus 4 should be. Oh. And that should be E. And then E is the image of C under a single transformation. Describe fully this transformation. So you can say that C and E, actually just looking at it, you can see that it actually is a reflection of each other, but the reflection line would be just right in the middle. So what we're gonna do, we're gonna try to draw a line right in the middle. So let's just see how it goes. It is actually being moved to a little side. Yep, that should be more accurate. So yeah, we can see that we just need to know the gradient of the line. So here it says 0, 1, and then 1, 0. So it means we know that it's going to be, you can get the coordinates and actually do the gradient as well. But here you can actually exactly see that because it's going that way, and it's like 0 plus 1. So that's just going to be x plus y equal 1. That's how you know the line. So yeah, you can say describe fully the transformation, reflection. And because reflection does not have a center, you can just say reflection, and the equation is going to be y plus x equal to 1, or x plus y equal to 1. So that's it for the reflection. And okay, number 4. Number 4 is that triangle A and B drawn. B is the image of A under the reflection of the line with equation y equal to minus x. So it's just going to go through here. On the grid, draw a triangle labeled B. So you're just gonna, yeah, there you go. And then it says it has to be a reflection of B, right? So we're just going to reflect. So that's just going to be minus 4. And then 1, minus 1. So that's going to be right here. And then it should be 5. So that's got to be 2. There you go. And there has to be minus 7, minus 8. Because it was like 8 and 7 here, so that's going to be minus 7, minus 8, which is right here. Just draw this. You can actually note that this is B. You can see that it actually is a reflection, and A is transformed to triangle C under the translation minus 9, minus 2. So what we're going to do, A is to C. Minus 9, minus 2. So you can go 1, 2, 3, 4, 5, 6, 7, 8, 9, and minus 2. Oh, 1, 2. So that's this part, and then if you want this as well, 1, 2, 3, 4, 5, 6, 7, 8, 9, minus 2. So it's going to be here. Oh god, just gonna erase these lines because it's a little distracting. Then you have this one as well. Minus 9, minus 2. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, minus 2. So that's right here. So you're just going to draw it. You're just going to connect them. So that's why you get your C. And then describe fully the transformation that maps A onto D. A to D. So we can see that even here we can see that the size, there is a size difference. So we know that it actually just shrank. So we know that scale factor definitely has to be in the minus because it's smaller. If it's smaller, it's minus, but if it's larger, we know that it's going to be plus. But for now, we know that it is enlargement. We don't need SF. We need the center. So what we're going to do, we're just going to combine all the points again. Okay, this is actually not working that well. Let me just try drawing the line again. Not sure if I can. Yeah, should be okay. And then you have this. and you can kind of just see where the center might be already. You keep doing this, which is actually a little weird, but yeah, it should be. Oh, okay. So yeah, we kind of get that it should be just around there. So we know that it actually is smaller. You can see that it actually is smaller by 0.5. So that's minus 0.5. Center, 6 comma minus 1. And that is your single transformation. And then number 5. 5 it says triangle A, B, and C are drawn on the grid above. Describe fully the single transformation that maps triangle A onto triangle B. A to B. We can see that it actually looks like they're being reflected. So we just need to find where is the center of reflection. You can actually count the grids, which you would see like 1, 2, 3, 4, 5, 6. So we know that it's going to be at 3. And which is here. In this case, it's at minus 2. So you can just say that reflection sorry, not x, y go to minus 2 because it's horizontal. And A onto C, A to C, we can see that it's the same position, so it might be translation. So what we can do is count 1, 2, 3, 4, 5, 1, 2. So that's 5, 2. And it's going left, so it's going to be minus 5, and going out, so that's plus 2. So translation, minus 5, 2. And A onto D. A onto D, here we can't really see, but A onto D, it looks like it's actually a reflection, and we can say that it's actually anti-clockwise. So it's going from this way to that way. That's why it's showing anti-clockwise, because if you go from this way, this pointer has to be on the other side and not this side. So going this way, it means it's going anti-clockwise, and it is 90 degrees. For the center, usually you can use a tracing paper to find it, but here we can say that it is only going to be at 2, minus 1. That's where the rotation has to be. Usually you can try to check around 0 point, and you will see if it's matching or not, and then you see that it actually has to be somewhere lower or not. So you say that it's just going to be rotation anti-clockwise 90 degree at 2, minus 1. Yep. And it says triangle E is the image of A onto the enlargement with scale factor minus 2. And center of enlargement 4, 0. So E is the image of A under enlargement scale. So it means E is going to be bigger. So on the grid drawing, label triangle E. So it says it has to be bigger, and it's at 4, 0. So what we're going to do is that I'm actually just going to erase this for a while. It says 4, 2. Wait, or is it 4, 0? Sorry, it's at 4, 0 enlargement. So it's gonna cross here. So what we're gonna do is that it's here at this point, right? And then we're gonna do, we're gonna have to do this as well. Nope, because it has to be a 4, 0. Well, it needs to go a little up. Give me a second. I think it's actually a little bit of center. Because I will probably be estimating, because this one might not be really accurate, because I'm doing it on here. Because the graph is a little changed, but I've believed it should be right here. And this one has to be here. So that means the other side, which is this side, go through. Yeah, has to be right there. So it's gonna be here. Oh, sorry, it has to be here, I believe. Wait. Let me just try again because the center is a little off. So then you're gonna have 4, 0, right? Okay. This one. Yeah. Okay. This might be correct. It has to be here. Yeah. Because it says, if the scale factor say -2 as well. Yep, so that's it. This should be E. So you've just got to make sure that your center is kind of correct. Sometimes it might actually go on to like another point, but just make sure that you're counting that it's scale factor -2 as well. Just see that if it's like twice the amount or not. So yeah, we are done with D. Yep, and this should be 6. So what it says is that trapezium P and Q are drawn on the grid opposite, and that describes related a single transformation that maps trapezium P onto Q. So P to Q, we can see that it's actually will be enlargement because it's being bigger. We just need to find the center, and the scale factor should be 2 as well because it got twice larger. Oh, sorry, twice. Yeah, twice more. Wait, twice. P onto trapezium Q, so that's P to Q, so that's smaller, so that's 2. Yep. We're gonna do this first. Yep. I can see where it might be going. Oh, because usually if it's kind of these kind of graphs, they actually have a certain coordinate, so it's not going to be either 0.5 or not unless they specify that it's 6.5. So we know that it's somewhere that's going to be around here because it's has to be an official coordinate. So let's just try and keep going. Because it's just a estimate that I can do on the graph. It's just gonna look a little messy. But we know that it's gonna be right here. So that's just going to be enlargement. Scale factor 2 at 6, -2. So enlargement s f equal to 6, -2 center. Yep. And then what we're going to do is P is transformed onto A under the translation 2, -3. P to A 2, -3. So that's 1, 2, -1, 2, 3. So what I'm gonna do, I might just erase all this because it's gonna be, yep, 2, -2. So you have 4. So that's why you got 4. Sorry. Right there. And that is A. Yep. It says P is transformed to B by rotation of 90 degrees clockwise about the point 5,2. P to B 5,2, so this is going to be right here. You're going to use the same method where you use your, or you're going to draw your P first and then on your tracing paper and then go 90 degrees clockwise. So you know the clockwise is when you go to the right. So then you should get around here. That's going to be right here. Be right here. There should be a B. It says C is the image of trapezium Q under the transformation with matrix M where 0 minus half half. So this time it's the opposite. This one's in Y, this one's in X. So we just need to make sure of that. So C, so we need to go get the Q first. Q's coordinates. So that's -4, 4, 4, 4, -2, 6, 0, 6. Oh sorry, yeah. -4, -4. Oh sorry, -4, 4, 4, 4, 0, 6, and and last one was minus 2, 6. Yep. And then you just do the same thing. So that's why you get C minus half, so that's going to be minus 2, minus 2. And then for 4, it's minus 2, 2, minus 3, 0, minus 3, minus 1. Yeah, so we're just going to draw it. Minus 2, minus 2. And then that was minus 2, 2, I believe. Minus 2, 2, minus 3, 0. Minus 2, 2, minus 3, 0. And then minus 3, minus 1. So that's like this. Maybe this way, this way, this way. And that is your C, I believe. Yeah, we'll try to see. That's it. And number 7. So it says that quadrilateral A and B are on drawn grid. B is the image of quadrilateral A under the single transformation system, smaller, so that's going to be a scale factor minus enlargement. You can see that it's already larger. We know that usually it's going to be enlargement. You need the SF and you need the center. We're just going to do the same thing. We're just going to conjoin all the coordinate, the corresponding points, and see how it goes. So yeah, this way. That is to here. So to that. Let me just have a look again. Let me try this first. Oh, this one's half, so we know that it's going to be around here. Yeah. Okay. Just right there. 1,5. And then you can see that it's smaller, so it's this one's only 3 twice, so that's minus 0.5. And center was 1,5. Yep. And that's it for today's video, so I'll see you in the next video as well.